So last time in class, we considered the case of four subintervals, which we indicate here in the sketch on the right. We just have four subintervals. And in this case, the system is so small that we can list all possible outcomes and their probabilities. And for the number of spikes, if we consider having four spikes in these four subintervals, there's only one way to get it. We flip our coin four times and we get H, heads, each time. And we calculate the probability of this occurring, where we said the probability of heads, a spike is small, it's 0.1, while the probability of tails, no spikes, is high, it's 0.9. And in this case, the probability of flipping our coin four times and getting heads four times is very tiny, 0.0001. So very unlikely that we'll flip our biased coin four times and get four spikes, or we'll get H four times. Instead, we can look at the probability of observing three spikes, and we can list all possible ways we can get three spikes. We might get tails on the first flip and then three spikes, or we might get a spike and then no spike, a T and then two spikes, and so on. So we can list all possible outcomes with three spikes and compute the probability of that occurrence of any of those four patterns representing three spikes. We can repeat this procedure and calculate the probability of observing two spikes, and there are lots of possible ways we can get two spikes, whether those spikes occur at the beginning and the end or somehow dispersed across the four flips. And then the probability of one spike and then no spikes. And notice in no spikes, we flip our biased coin four times and we get T each time. Another thing to notice is that the sum of all of these probabilities of observing four spikes, three spikes, two spikes, one spikes, or no spikes, the sum must be 1, because we've listed all possible outcomes here. If we flip our coin four times, we're going to either observe four spikes, no spikes, or something in between. We've denoted all the outcomes here. So if we flip our coin four times, what is the most probable outcome? Well, in this case, it's not observing any spikes. The probability is 65%, 0.65. Now, in real life, we don't expect to have four subintervals. We expect to observe many more subintervals. So if we let m get very large, and this represents the number of subintervals, we make this much larger, as indicated in this figure. And we might consider the case, instead of four subintervals, let's consider 10. So that's fine, we can consider this case, and let's start listing all possible outcomes in 10 flips. And we could try to do that. Maybe you'll get started right away, and let's try to write down all the possible outcomes. And we'll consider the case, just to start with, of observing 2 H's and 8 T's. So that covers our 10 flips. And we can try to just write down how these flips will occur. Right, and so maybe the two flips occur HH and then a bunch of T's, and then we flip our coin 10 times, we observe a spike, and then no spike, and then a spike, and then a bunch of no spikes. And we flip our coins again, and in the first position we observe a spike, and then two tails, and then another spike H, and then nothing. And we could try to list all possible outcomes that have two spikes. And maybe if you try to do this on your own, or maybe you can visualize this in your head, that this is going to be easy or hard. Well, it's not that hard to do, right? We can list all possible outcomes, but when we would think about what's the probability of making a mistake in listing all these possible outcomes? Well, it's very high. And although it's easy to do, it's very tedious to do, writing out this entire list. So that's not what we're going to do. We will not list all possible outcomes for 10 coin flips. And what we'll need is something better than tabulation, than trying to tabulate all of these different outcomes that we could possibly observe. And what we'll use instead is a formula, and that formula is called the binomial distribution. And I'll write it down here. So this is the binomial distribution, and we'll spend the next few slides thinking about this distribution. Now let's define all of these terms to start with. B of n represents the probability of observing n heads in m coin flips. So we flip our coin m times for our subintervals, and we're going to ask the probability of observing heads, or a spike, n times. N is the number of heads that we observe. Again, m is the number of coin flips. P is the probability of getting heads on a single coin flip. And 1 minus p is the probability of observing tails on a single coin flip. Notice that if we add up these two probabilities, the probability of heads plus the probability of tails, we get 1. Because we have a 1 minus p plus p, those p's cancel, and the probability is 1. We either get heads or tails. And what we'll do in the next part of this lecture is we'll consider each of these terms within the binomial distribution and try to figure them out.